what we were talking about was two different ways of plotting a point. The sketching of a point, of plotting a point, we've got two different styles. One is Cartesian and one is polar. The Cartesian will be x and y, which is going to be the distance measured on x-axis from the origin to x coordinate, and the distance measured from origin on y-axis or parallel to y-axis to y coordinate. And then once you have the x coordinate and y coordinate measured on the point. Now there is another way of doing the plotting the point. Taking the distance from the origin to the point, joining the point from the origin, and from the initial line is nothing but x-axis, the Cartesian. So we just, what you do is, to measure the angle from the initial line where till it meets the R, and whatever that angle is measured there, so that gives you the second coordinate, that R and theta. R is the distance and or length of the radius, okay, from the origin, and the angle and anti-clockwise direction. So this also can help you in getting a point. So this, because you see that when we have done the rational function graph, we have drawn the rational function graph. I want to hear what I'm talking, so I just make the call. You just keep the call on, but don't talk, okay? You can hear what I'm talking. All right? Can you hear me, right?
Yeah, doctor.
Okay. So now, what are polar coordinates? Polar coordinates are taking a different measurement to plot the point. Okay. So that is what I did yesterday. We had the point, so we have drawn the axis and y-axis. We got the point, and point I have written as x and y, and so this point will be, now you got you can see the board, right?
Yes, can see.
X and y, and this is what I did yesterday. I'm doing the same thing. So here, what we have is, this is your x, this is your y, and this is your r, and your theta. So we can use x and y to fix the point, or we can use r and theta to fix the point. Correct? Yes or no?
Yes.
Yes.
Now what we have done is, I have already written the relationship also, right? That is x is equal to, so basically this is what we will be using. Basically x is equal to r cos theta, y is equal to r sin theta. So if we have got r and theta, then we can write down in terms of x and y. Then we have written r is equal to x square plus y square square root, and r is greater than 0. This you will keep in your mind. R is greater than 0 in every case when polar coordinates are being used. In harmonic form, in complex numbers, in polar coordinates, wherever r theta is being used, r is greater than 0. In this context, I want to tell you one thing, that when you are doing, if you are using any software to check whether your polar curve is, you have drawn it correctly or not, the software is going to show you double number of curves. The curves which are with R and which are with positive and which are with negative. So you have to be very careful in using that. And then x is equal to, not x is equal to, it should be cos theta is equal to so cos theta is equal to x by r. You can remember it this way, or it will be completely changing into x divided by x square plus y square square. So sin theta will be y by r, which is y divided by x square plus y square. So this will be changing to Cartesian, and this will be changing to polar. So these are the relationships that we have in the. So this is connecting Cartesian and polar. So any questions?
No.
No.
No, yesterday there's some confusions were there, right? So that's why I just want to ask you if you got any confusion, then you can ask me. Otherwise, we can proceed to the next thing. Yeah. Does it look similar to what you have done in your class, isn't it? In your what do you call the so Amal, you can see what I have done on the board and I've sent it on the group. Okay. All right. So now what I'm doing is I will just remove these things what I have done on the board, and we'll start with the exercise 3B. I think there was some problem with the file. We couldn't see the question. Is there any problem in seeing the file there?
No.
Okay, so now here what happens is, and now anyway I'm going to send this to you now. So this is what we are going to do, exercise 3B. Yours is block 2, right? So sometimes thinking that it is your block, I send to the same block. Okay? Alright. So what we'll do next is, we are having that exercise 3B. I think 3A should be very easy for you to work. So the first question is, what you have is Find the Cartesian equation of each of the following. So the relationships or connections which you have written just now are the ones which you are going to be using and changing r and theta in terms of x and y. So question number 1, A, is the simplest thing, r is equal to 4. When r is equal to 4, then we just substitute the value of r, x square plus y square, and square root, and 4, and therefore x square plus y square. So this is the, see that this is the equation of circle with radius 4, isn't it? And this is r is equal to 4, that is your polar equation of the circle. This is the polar equation of the circle in Cartesian equation of the circle, which we already know. In these questions, not much of your simplifications are required. Just do as much as you can, and you can leave it. As long as you're using the correct relationship, it's fine. So r sin theta is equal to 7. So r sin theta is equal to 7. That means x is equal to 7. Remember here, whenever you are having cosec theta and secant theta, you draw the, okay, so here to plot or to sketch secant theta or cosecant theta curves, change it to Cartesian form. Because if you see the cosecant theta, secant theta curves are like this, isn't it? So they are like this and then like this, right? So kind of disconnections are there, which will be not good for the curve to draw. It is not a continuous curve. When you see tan theta, cot theta, the sine, cos, and all that, they are in terms of connected ones are there. So it is not good for us to, or it doesn't give you proper curve when you got sine theta and cos theta. So we change secant theta or cosecant theta curves to Cartesian form, and we draw the curve. Cartesian. Okay. So here this is on. So this something like this. It comes in secant, then you change it to sine or cos, and then do it. B, question B. Now see here, simplification part I am showing is 1 plus cos theta. Now r is x square plus y square. A, 1 plus cos theta is x by r, isn't it? So x by x square plus y square, square root, and then what you do is you take the common denominator. We are just doing enough, not less, not more, and whole divided by x square plus y square, square root, and then what you do here, you bring this square root from the denominator and then just write down x square, so x square plus y square is equal to a square root x square plus y square plus x. And that's it. We don't do anything more than this. Yeah? Is this okay?
Yes.
So here our main idea here is to change it to Cartesian form, and then we are just doing enough what is required. Okay, so we go to the next question. The next question we will do is F. So I'm going to remove this now. So here basically, remember one thing, basically what we are doing is, we want to make sure that we just use the coordinates accordingly, what we want and what we do not want, and depending on that, we are doing it, and we are making, there is one thing you should keep always in mind, do not have the idea of drawing the changing polar curves into Cartesian form and drawing it. A polar curve has to be drawn in the polar form only. It is only for secant and cosecant that you change it to Cartesian and do it. Is it clear? So rational function graphs, you see when you have drawn your rational function graphs, what did you do? You never got a flower, isn't it? Never got petals, never got a heart. But here you will get all those petals, flowers, and circles and all sorts of things. You get spiral, you get all sorts of things here. Yeah. So if you are asked to change it, you change it. Otherwise, for drawing purposes and all, we will not look for changing. We will just look for sketching the graph as it is in the polar form. Except that we have secant and cosecant, which needs to be changed to sine and cos. So here we have question number 1F, which is 2 by r is equal to 1 plus cos. So 2 by r is x square plus y square by 2, 1 plus cos theta will be x by x square plus. Now we can easily do simplification, isn't it? 2 x square plus y square is equal to x square plus y square, you bring it up here, plus x and divided by x square plus y square and finish. So you just do the cancellation and write down the answer as x divided by x is equal to square root x square plus y square and plus x and divided. With x, I think it is 2 here, not x. So that's all you will do it here. Okay? Now, does it look okay now?
Yeah.
Yes.
Any kind of confusion that you had yesterday? Can anybody tell that you got any more confusion remaining? If it is not, then we can start with question number 2. We are okay, is it? Okay. So now we go to the next question. Next question is find the polar equations. Now we change to from polar to Cartesian. Now we are going to be changing to the other way, that is now the first question you can see immediately, isn't it? Question number 2. x square plus y square is equal to 9. So that means here x square plus y square will be r square 9 and r is equal to 3, and here there should not be any doubt about plus minus sign because r is always greater than 0. Now b is xy is equal to 16. Now xy is equal to 16, x is r cos theta, r sin theta is equal to 16. And what we do here, we don't need to do anything, any other simplification. Sin theta cos theta is equal to 16 and that's it. Now we can go for C, x square plus y square, x square plus 9, y square by 16 is equal to 1. Can anybody tell me who is preparing for Cambridge and Oxford, what is the name of this curve? It is a standard curve, standard conic actually it is. X square by a square plus y square by b square is equal to 1. Anybody heard about parabola, hyperbola, ellipse? Oh, okay, if you have not heard it, I'm fine. This is the equation of ellipse. So here, we just need to r square cos square theta by 9 plus r square sin square theta by 16 is equal to 1. You can leave the answer simply like this. Because even if the numbers are different in the denominator, if you take the common denominator, then even common denominator, maybe you can change the equation in terms of sin square theta or cos square theta, but it will not become, because the numbers are different, it's not going to be simplified, except that some more simplification is possible. So you can just stop there. And when I'm doing F, now here you see that how do we know where do we stop? The thing is that we are not given any answer to show. So since we have not given any answer to show, it means that you can, what is your main objective? Change into the polar form. So as long as your equation is completely changed into polar form, and if you can find easy, quick simplification, we do it. If not, we just leave it that way. Make sense? Now here, the next one we are doing is F. F is x square plus y square whole square is equal to x square minus y square. So this will be, what is this? R square and the what? Whole square. Then this will be r square cos square theta minus r square sin square. Yeah? And then what we can do is, we can take out r square common and cancel it. So r square is equal to cos square theta minus sin square theta, and cos square theta minus sin square theta can be simplified as
Cos 2 theta.
And r, and can I write down here square root. So this can be a curve which we may be, in course of time, we may be drawing there. Yeah. Is everything okay?
Yes.
Yeah.
Okay. Now what we will be doing is, right, you will take a 5 minutes break, and I will be coming back in 5 minutes time. Because I need to bring the book from because I don't have the book, and I'm going back and forth in this. So, Amar, you can stay online or you can just join after 5 minutes, okay? Sorry guys, I'm back. Everything seems to be going wrong. So, alright. You're all there? No.
Yes.
Doctor.
Okay, so now what we are going to be doing is, I think I've sent one more document to you just now. Did you all get it? Yes or no?
Sorry, doctor. Document on WhatsApp or Teams?
On Teams.
The one with exercise 3A and 3.
No, not that. That was only one. I think when I checked that in your blog, you had only one document there. Now I went and got this sorted out, and then I think I will check and copying this whiteboard. Into- Can you see the whiteboard or no?
Yes, we can.
Okay. I think they just check if you got a new document there or not. If not, it is okay. You can see, work it out what I have sent there. Just check whether you can find it. I've just uploaded it there. Okay, now what we are going to talk about is we are going to be talking about now what are the features that you will be to sketch solar surf. Significant features. What are the significant features? That is my question.
Symmetry.
Number one, symmetry. Okay.
The least and greatest values of R.
Sorry.
Least or greatest value of R.
Greatest or so significant features to this to sketch the curve. We have got symmetry, we have got the greatest and least value of R. Okay.
The coordinates of intersections with initial line.
Coordinates of intersection. Intersection with
The initial line.
initial line or is it pole?
Sorry? Initial line.
Initial line.
Okay, initial line.
And also the form of the curve at the pole.
Form of the curve. Okay, anybody want to add anything here? When we talk about symmetry about what? This symmetry we will talk about initial line, okay? Or it may be theta is equal to pi by 2. When I say initial line, it means theta is equal to 0 or theta is equal to pi plus or minus, no, minus pi if you are going in whichever range that you are taking, or it is plus minus pi by 2 or minus 3 or plus 3 pi by 2. So basically, most of the time, these two will be important things for us to notice. Okay, so we talk about the symmetry. Okay, so the symmetry that we are talking about is now going to be, so let us now say that what is our symmetry. So there are two features that we talk about, polar equation and graphs. And just sending you the picture if you have not got the document there. Some days are not your days. Yeah, everything is going in such a slow as well as I don't know. Anyway, so let us get this. First, you get this document. Look at, open it in WhatsApp, and we will discuss about that. Okay. Now this symmetry we are talking about for sine theta and cos theta. So the symmetry about the initial line will be, did you all get the paper?
Yes.
Okay. Now you see here what we have got in polar coordinates. The points r and theta and r and minus theta. How will we this r and theta and r and minus theta? So if you have your polar curve, theta is equal to 0. If your point P is here, that means you should see that when you are measuring the angle, your angle is in the anti-clockwise direction, right? The positive angle. So the negative angle is going to be here, the point will be here, P, let's say dash, R and minus theta. So this point will be, P dash will be reflection of P in theta is equal to 0, right? So this will be
Yes.
minus theta. So now that means we are looking at the reflection of P r theta through the initial line. So that means we are talking about, so this point has a symmetry to this point through the initial line, theta is equal to 0. So theta is equal to 0 or initial line is the same thing, right? So now what is going to happen is, we are going to be, now if we look at cos theta, cos theta is equal to cos of minus theta, correct? So when cos theta is equal to cos of minus theta, so whether theta is positive or theta is negative, so cos theta positive, you get the point here. Cos theta negative, you get the point here. So that means the cos curve is symmetric about, so we say that cos curve is symmetric about initial line. You can see the figure there that I think the figure is very dim there. It didn't come very clear. That is, in polar coordinates, the points r theta and r minus theta are symmetric with respect to the polar axis and to the initial line or x-axis. So that is why, for example, cos of minus theta is equal to cos theta. So cos curve is going to be symmetric about initial line. Okay?
Yes.
Next we talk about the points. Now we are talking about, let me just remove this. Now the second situation is that we have got r is equal to r theta and r phi minus theta. Now r phi minus theta will be, you have got a point here, P r n theta, and this is your P, this is your theta, this is your r. Now if it is, both of them are same, phi minus theta will be the point that will come here, isn't it?
Yeah.
You can see that in the figure that I have given you. I think the internet connection is again going wrong because I cannot click on anything now. The cursor is jumping. So here we are phi minus theta. So this is okay when we take sine phi minus theta is equal to sine theta. So this means that the point which is there in the PR theta is reflected through the line theta is equal to pi by 2, that is gone to the here. So we can say that sine curve is symmetric about theta is equal to pi by 2, which is our y-axis. So this is the talk about the symmetry, but this is only possible for us to talk about few of the standard curves. So other curves we will have to see how it goes about. So symmetric with respect to, so you just go to the next page now. Symmetric with respect to polar axis will be when if you replace theta by minus theta and the equivalent equation, that means you are not going to have any change in the equation because we have just now written, isn't it? Cos theta is equal to, so we have got cos theta, cos minus theta is equal to cos theta. That means any curve which gives you this kind of relationship. For cos theta, sin theta, we can straight away talk about this. But for other curves, if you want to check, then we just replace theta by minus theta, and if you are getting exactly the same curve back, then that means it has symmetry about initial line. And similarly, what we have is cos phi minus theta. This is not cos, this is sine. So sine theta. So if any curve, if you can replace by pi minus theta and it gives you back theta, the same equation, then we say that it has a symmetry with theta is equal to pi by 2. But these things I think will be good enough for us to when we are doing sine theta and cos theta. Other than that, I think we should be okay while we are drawing. To test these tests given are sufficient conditions. It says that there are sufficient conditions, but it is not necessary to happen that way. So we will just restrict it to the sin theta and cos theta curve, which will be good for us to work out in the starting. Okay. So what we now want to do is we want to start. There is exercise 3C is there, isn't it? Now, I want you guys to draw dotted circles, just like what the picture shows in the second document, second page. Can you see that? Is it clear or not? I start doing here, I don't know, when to get something. Yeah?
Doctor, exercise 3 what? 3C.
Sorry?
Exercise 3 what?
Now what you do is, we want to start drawing the polar curves. So first we'll draw r is equal to cos theta. Okay? Between
Okay, yeah.
0 less than theta less than pi or minus pi plus pi. This is what we are going to do. So what we do here, we will be in the starting, we are going to be drawing, making the table.
Doctor, is this exercise 3C?
Yeah, no, we just don't go there. There's no need to go there. We will just start in general now.
Okay, so, okay.
What I want is, I want to start with the table. This one. Okay, so here we have got r and theta. So we make r and theta. This is, but as we, for polar curve, we get x and y, we just do r and theta. So it is 0. So cos 0 is 1, correct? Now what I want you to do is, write down 30 degrees, 40 degrees, easier for you to use it. But here the table that you are drawing is not going to be important. They will not look at that. They will just look at what we are doing. So that is 30 degrees is what? And cos 30 is? Cos 30 is? How much is cos 30?
Square root 3 over 2.
Divide
I want the decimal value now. Because we are sketching
0.8660.
0.866.
0.86. Okay. So then we go to 45. Cos 45 is 1 by root 2. How much is that?
0.707.
707.
0.707. Okay.
7, yeah.
Then we go to 60. 60
Half.
is 0.5.
0.5.
Okay. Then we go to 90 and that is
0.
0. Now when we go to the second quadrant, that is supposing I want 135 or 120. Now r and theta, guys, I'm so sorry, this is theta and this is r. So if you want 120, then what you will get? Cos 120 is how much?
Negative 0.5.
Negative
0.5.
0.5. Are we going to take this value? Does this value exist for us?
Oh,
No.
it just cannot be negative.
Now here, in second and third quadrant, right? The cost value is you get a minus r, isn't it?
Yeah.
That means second and third quadrant, the polar curve for cos theta is not going to exist. If you use the software, it will show you two loops. But here we are, because for our purposes, as soon as we get the value of r is negative, you are not going to get this curve there. So these values till you reach to 70 will not be there. Now, what we can do is, I'm going to remove this and this one, so what we are doing, cos theta is, we have got that, it is symmetric about, what did we do just now? Symmetric about initial line, right?
Yeah.
The initial line.
Yeah, so like that means here what we are going to be getting, whether it is plus minus 30, you're going to get the same, plus minus 45, you're going to get the same, plus minus 60, you're going to get the same, plus minus 90, you're going to get the same. Correct? So now what we do is we can start sketching the curve. For sketching the curve, what I want is, because here we are between 0 and 1, so you draw the circle. Okay, you draw the circle, then you draw the lines, and why I am taking only 2 here, this is theta is equal to 0, and this is theta is equal to pi by 2, this is theta is equal to pi, and theta is equal to pi by 3 pi by 2. Now what we are going to do, we are going to draw the lines here. Theta is pi by 4. Theta is pi by 3. Theta is pi by 6. Now you can use color pencils and whatever. Now we start marking. So for marking, what I'll do is, I'm starting to sketch. Okay, so this is the first point. Theta is 0, r is 1. So this is 0 0.5, 0.5, and this is 1. So here write down this is 1 and this is 0 0.5. So I start finding. So you can have one more circle also, no problem. Okay, 1. Now next one is 0 0.8. So 0 0.8 I'll just mark somewhere here. As I'm marking here, I will be marking the reflection also. Let us do this first anyway. So the next one is 0 0.7. Then next one is 0 0.8. Because of this. So then next point is I need here to have 0.5 and then I come back to 0. So I have got this curve now. Because of the symmetry, what I'm going to do is I'm going to be drawing the circle here. Is it okay?
Yeah.
So what you will do is, once you start doing the questions, then you will start getting fair ideas about how to draw. So you just first, when it is sin theta cos theta, you will just think of the symmetry, and then you will see that we are just doing the cos theta. So we will be doing cos 2 theta, cos 3 theta, cos 4 theta. So that is when we will be looking for the symmetries about different lines because of the multiple angle. Any questions? Do you have any questions?
No.
Okay, so what I want you to do now is, I want you to draw. Can somebody draw it? Anybody has got the pen to use it and can draw it on the board here? Is there anybody who has got the board, the facility to draw? Yes or no?
Yeah.
Anyone got tablet?
Yeah, I'm using a tablet now.
If you are using the tablet, I think you can draw it. So can somebody try to draw it on the board so that others can chip in your ideas?
For which question?
R is equal to sin theta.
Okay. Do I have to do the table of values also?
Yeah. This because initially, see, we are discussing, as I told you, we will not be strictly required to have the table and all this. But when we are doing the starting, we just let us make sure that we have got the ideas. And then later on, you can start drawing things directly, thinking, what you can do and what you cannot do.
Working.
Is there anybody who is doing it? Nothing is happening on the board.
I don't know why my iPad is glitching out. Hold up. Um,
Okay, so what we'll do is I'll start this. So R is equal to sine theta, and sine theta is symmetric about. We just now have spoken about symmetry, about the sine theta is equal to pi by 2. That means you see here, when you got sine theta is negative in third and fourth quadrant, isn't it? So that means we are not going to get any curve. So theta is equal to r and theta. So we just have initial values. Sine theta, if theta is 0, r is 0, theta is 30, 0.5, 45, 0.7, and 60, 0.866, and 91. We need, and then we know that when you go to the second quadrant, so 180 minus 30, 180 minus 45, 180 minus 60, and 180 are going to be the same value. You understand what I'm talking? So here, again we have got a circle, another circle, then you got the line, theta is equal to 0, you got the line, theta is equal to pi by 2, then you got theta is equal to pi, and so again between 0 to 2 pi we are doing, theta is equal to 3 pi by 2. Then what we do is, we make the line 45, pi by 4, pi by 3, and pi by 6. Now we do the points. I think what we can always do the similar situation here. So we have got the points reflection. So what we do is here is, red will be better. So we do theta is equal to 0. So that means the point is here, correct? The first point. Then you got 30, sin 30 is half. So what? This one. So here 0.5 is there. This is our 0.5 and this is 1. You will have to mark here. That is your marking. So the next one is 0.7. This next one is 0.8, and then it touches 1. Then we are going to have the similar points of reflection here, then here, then here, and it comes back. So we are going to be now drawing a circle with this. That will be your r is equal to sin theta. Okay.
Doctor, is it a semicircle?
No. It is a circle. It is not
Oh.
semicircle.
It's a full circle,
It
right?
is a circle. Because my line theta is equal to 30 has gone very close to the initial line, isn't it? It is a circle. As I told you, the software will show you 2 circles. If you have got any software, then you can just see that. It's almost, I think there's no need for us to worry about the doing it. That is almost whatever. Yeah?
Okay.
Doctor,
Mhm.
I was wondering, like, can we now use the polar graph paper, which they already marked the angles?
Do you have that kind of paper with you?
Uh, uh, Wait, I actually did the question. I'll send it and see whether it's okay.
No, because here, that is why I wanted you to, because in the examination, they may not give you the circles there. You will have to do it yourself.
Oh yeah, because I can't find a compass now, so.
No, you can, but when you find out later, because today the class is almost finishing now. Is that okay?
Yeah,
Can you
okay.
just put the compass later? Yeah? Yes or no?
Sorry?
No, you can get
Sorry,
hold of
Doctor, what
compass
did you ask?
later. You can find the compass later, right?
Yeah.
Now you draw it with compass and proper circles. If you got a polar graph paper where the circles are marked and because here you see that all theta pi by 2 pi by 3 theta, and then you are marking the values of r is equal to 0.5 with 1 and all that. This you have to be doing that all the time. It's not that you can do away with it. Okay.
Okay.
I think I'm not giving you any homework. We will see some questions tomorrow. Then we'll go to do. Okay? Well, again, we just have started. Yes. Yeah. Yeah. We can send it. Send your sketches to, because this two only I'm doing it, right? I'm not doing anything more. Okay? So I think over and out, guys, today we had a lot of issues, technical issues. Sorry about that, we can't help it. You may also have it, I may also have it. So this is how it could be. Technical features. Okay? Over and out. Bye-bye.
Thank you, Doctor.
Thanks, doctor.
Yes, doctor.